All right, I'm gonna go over Exponent Rules Part 3. This is the final part for Exponent Rules. We did this in class on August 21st and 22nd. So if you were absent, make sure you watch this to get all of the notes. Okay, so we started with a warm-up. You can see problems 1 through 5. It should be somewhat review. If you look at number 1, just keep in mind what we're really thinking about is for the square root of 25, we need two things that multiply to get us 25. And they have to be the exact same thing. And so in this case, it has to be 5 times 5. It's the only thing that works. So the answer is 5. And a lot of these you probably know just from memorization. So like the square root of 100, well, that's going to be 10, since 10 times 10 gets us 100. The square root of 36, you know that's 6. That's because 6 times 6 gets us 36. And a little known thing here, if we don't see an index, a little number right here or here or here, we always assume it's a 2. So you may even want to just write that in there whenever you don't see a little number there. That's because there's two numbers that are going to multiply to get us this one. Two blank spots, you can think. And so down here we have cube roots. So we know we need 3 things that are going to multiply to get us this 27. So something times something times something is going to get us 27. The only thing that works is 3. 3 times 3 is 9. 9 times 3 is 27. So I know my answer is 3. Right, for this last one, it's another cube root. So I know I'm going to need 3 things that multiply to get me -8. And so you can try out some things, but if we have a negative sign, chances are we need a negative in these blank spots. So what ends up working is -2. -2 times -2 is +4. +4 times -2 gets us that -8. We know the answer is -2. Okay, and that brings us into some vocabulary. So the one that y'all probably know before this lesson is this symbol right here, this weird bar-shaped thing. We're going to call that a radical. And sometimes you've heard it called a square root, but in this case, it's not always going to be a square root. We just saw how it was a cube root up here. Could be a 4th root, 5th root. So we don't necessarily just want to say square root. The stuff underneath it, inside the radical, we're going to call that the radicand, spelled like this. So it's everything inside the radical. And then this little number right here, we're going to call an index. And so I'll say these vocabulary words throughout this lesson. And it may seem a little weird that we're talking about radicals when we've been talking about exponents this whole time, but that's because they're closely related. We can go from radical form to exponent form or vice versa pretty quickly. So just looking at this, hopefully you see some of the similarities. So the index here, that is coming from the denominator when it's an exponential form. And the exponent here, that can be found in the numerator when it's an exponential form. So just kind of keep that in mind when we're going through these example problems. And there's different ways to go about this. I tend to always work with it when it's in radical form and do sort of a guess and check method. I think that's just the easiest, but there's other ways to do it, and I'll show you some other methods too in this video. So for number 1, we have 49 to the 1/2 power. So whenever you see a fraction in our exponent, you may just want to go ahead and draw a radical. We know we're working with radicals. The index, this little number right here, we said, okay, the index, that comes from our denominator. So looking at this problem, our denominator is a 2. We know our index is going to be a 2. And then the radicand, the stuff underneath, well, that's going to be 49 to the first power. Remember up here we said the exponent comes from the numerator. So my numerator is 1. So I know that's my exponent. But an exponent of 1, that doesn't really change anything. It's still just 49, so I didn't really have to put that 1 there. So now we just have the square root of 49, which you probably know. But if I were to write this all out, I know I need 2 things that multiply to give me 49. So obviously that has to be 7, right? 7 times 7 gets us 49. So our answer is 7. Okay, on to number 2. So again, I have a fraction in my exponent, so I'm going to go ahead and draw my radical. My index in this case looks like it's going to be a 3. And then my radicand will be 8 to the first power. Again, I don't have to put that 1, since 8 to the first power, we know that's just 8, but I'll leave it there. So now we need 3 things that multiply to get us 8. So something times something times something is going to get us 8. What ends up working is 2. 2 times 2 is 4. 4 times 2 is 8. So we know the answer for this one is 2. So obviously this is going to get a bit harder, so don't stop watching yet. Always start easy. Okay, so let's look at 3. This is unique since we have a numerator other than 1. So anyway, it's a fraction in my exponent, so I'm going to go ahead and draw my radical. Index will be 3. My radicand, the stuff underneath, that's going to be 27 to the second power. And so, of course, for this, your first thought may be to just do 27 squared. But 27 times 27, that's a pretty big number. And we don't have to work with numbers that big. We can do this trick. So I'd like to circle this piece. We could start by doing the cube root of 27. That's a pretty easy problem. Something times something times something that gets us 27. You probably know that's 3, right? 3 times 3 is 9. 9 times 3 is 27. So I'm going to replace this circle with a 3. And then I just have to bring down this 2. And so now we have a much more manageable problem. 3 squared, that's just 9, right? 3 times 3 is 9. Okay. And for number 4, so I'm going to start by drawing a radical. Now we're dealing with a 5th root. My index is a 5. My radicand is negative 32 to the first power. And the parentheses are only there because we have a negative sign. So that's just saying, okay, we want to include that negative when we're raising it to the 1/5. You don't really have to put parentheses. I like to put parentheses around negative numbers. Okay, so now we need 5 things. Something times something times something times something times something that's going to multiply to get us a negative 32. And so the more you do this, the better you'll get at it, but you may want to test some things out. And your first thought might be a 2, right? 2 times 2 times 2 times 2 times 2, but that gets us positive 32. We need it to be a negative 32. So hopefully that's when you go back and try a negative 2. Negative 2 times negative 2 is positive 4. Times negative 2 is negative 8. Times negative 2 is positive 16. Times negative 2 gives us that negative 32. So our answer is negative 2. Okay. For number 5, so some students wanted to, for this problem, they said, hey, do I do 64 plus 81 first? And no, that is not possible. That's not right. What we're going to do for this is treat both of these separately, simplify both of these separately, and then whatever we get, we'll just add them together. So I have fractions in my exponents, so I know I'm going to need a couple radicals. So for this one, my index is a 3. My radicand is 64 to the first power. I guess I'll put that in there. For this one, my index is a 2. My radicand is 81 to the first power. And this one may take a little bit of guessing here, but we need 3 things that are going to multiply to get us 64. So you can try some things, but it ends up being 4. 4 times 4 is 16. 16 times 4 gets us that 64. So that one is 4. Okay, I took care of that part of the equation, or the expression. So now over here, this is a pretty easy one. Square root of 81. If you want to write it out, we know we need 2 things that multiply to get us 81. Hopefully you know that's 9 times 9. So this simplifies down to a 9. And now we just have 4 plus 9, which we know is 13. The problem is 13. Okay, for number 6, draw my radical. I know my index is going to be 2. My radicand is going to be 25th to the third power. And we can do the trick again because I don't want to know what 25 to the third power is. 25 times 25 times 25, that's going to be a really big number. So let's do this shortcut here. The square root of 25, that's much more manageable. We know that's 5, right? Because 5 times 5 gets us 25. So I'll just go ahead and write my 5. Then we'll raise that to the third power. It's still a big number, but we can just put that in the calculator. 5 times 5 times 5 gets us 125. Okay. On to the next. Okay, so for these, I'm going to treat them separately, and then I'll subtract the 2. So I'll go ahead and draw my radicals. So for this one, our index is 2. Our radicand is 4 to the 5th. And for this one, our index is 2, and our radicand is 4 to the 3rd. And I'm going to take the shortcuts again. I'm going to say, well, I know the square root of 4, that's just 2. So this is really 2 to the 5th power minus 2 to the 3rd power. 2 to the 5th, that gets us 32. You can put that in your calculator. 2 to the 3rd, that's just 8. And 32 minus 8, that's 24. Okay, for this last one here, I have negative 27 raised to the 2/3 power. Again, I'll draw my radical. My index is 3. My radicand is negative 27 to the 2nd power. I'm going to do the shortcut again. I'll take the cube root of 27 first. So that means something times something times something has to get us negative 27. Only thing that works is negative 3. Negative 3 times negative 3 is positive 9. Times a negative 3 gives us negative 27. So instead of this whole stuff inside the circle, I'm going to put negative 3. And then I'll have to square that. Negative 3 times negative 3, that gives us a positive 9. Okay, so all those problems we did without variables, but now I'm going to add some variables in. works the same way, really. So for this problem down here, it's already in radical form for us. If we don't see an index, we know it's a 2, so I'll put that there to remind us. So we're going to need two things that multiply to get us x to the 8th. Has to be the same term in both blanks. And this is kind of going back to Exponent Rules Part 1 where we learned the product rule. So the only thing that works here is x to the 4th times x to the 4th. And that's because if we're multiplying with the same base, we add exponents. 4 plus 4 gets us that 8. So for this one, our final answer is x to the 4th. Okay, let's look at a similar one here, number 10. It's already in radical form for us. We know we need three things now, something times something times something that's going to get us x to the 12th. And again, we're using the product rule, so it's going to be x to the something times x to the something times x to the something, where if we add all of the exponents, it's going to get us 12. So you may want to think, okay, x to the something times x to the something times x to the something. Well, what plus what gives us 12? It's kind of how you want to think about these. And that's 4. 4 plus 4 plus 4 gets us 12. So the answer is x to the 4th. And I'll show you another way to do this problem if the guess and check is a little too crazy for you. We could have converted this to exponent form. We could have said, okay, this is really x to the 12th all raised to the 1/3 power. Since that's our index, right? The denominator is always our index. And then you could just use the power rule. You could say, okay, 12 times 1/3. You just multiply across. That's 12 divided by 3. That still gives me x to the 4th. That's just a different way of thinking about it. Okay, for number 11, I'm going to just treat these separately, and then whatever I get, I'll just multiply them together. So keep in mind, we have an index of 2 on both of these. So for this first piece, the square root of x to the 10th, we know we need something times something to give us x to the 10th. The only thing that works there is going to be x to the 5th times x to the 5th. So this first piece right here, I know that's x to the 5th. Okay, now let's figure out the square root of x squared. So I need two things that are going to multiply to get me x to the 6th. So that has to be x to the 3rd times x to the 3rd, right? If we add exponents, get that 6. Okay, this piece right here, I know that's going to be x to the 3rd. Now we can just use the product rule. If we're multiplying with the same base, we're going to go ahead and add exponents. So this is x to the 8th. Okay, moving on here. So again, let's see, our index is 5. So now we need 5 things, something times something times something times something times something. That's going to get us this 32. Let me move this. 32x to the 5th. And so you may want to just focus on the 32 first. What are 5 things that multiply together to get us 32? And they all have to be the same thing. That's going to be 2. So out in the front of these blanks, I'll put a 2. And then we need 5 things that multiply together to get us this x to the 5th. Keeping in mind, we're going to end up adding the exponents using that product rule. So the only thing that works is x to the 1st. That's because if you add up the exponents, 1 plus 1 plus 1 plus 1 plus 1 gets us the 5. And so our final answer is going to be 2x to the first, or I can just leave it as 2x. Okay, number 13 down here. So for this one, I know my index is a 2, so I need two things that multiply to give me 100x to the 14th. And again, you could just start with the 100. Think, okay, what times what gives me 100? Hopefully you know that's 10 times 10. And then we have to think what two things will multiply to get us x to the 14th. So it's x to the 7th times x to the 7th. That's because 7 plus 7 gets us that 14. So our final answer is 10x to the 7th. Okay, for this next one, I'm going to convert this to radical form. You don't have to, though. I could show you a different way for this one, too, for all of these, really. But you could use the power rule and apply that apply that 1/2 to the 9 and the x squared. So that would turn into 9 to the 1/2 times x to the first, right? 2 times 1/2 is 1. And then 9 to the 1/2, well, that's the same thing as the square root of 9 times x to the first. And then the square root of 9, we know that's 3. So then this is really just 3x. So that's one way to do this problem. If we want to continue with the way we've been going, though, we're going to do a sort of guess and check method. So I'm going to convert this to radical form. I know my index is going to be a 2. My radicand is right here, this 9x squared. Technically, that's all to the first power. So I could put a times 1 here, but that just doesn't change anything. So I'm going to leave it like that. So then we need two things that multiply to get us 9x to the second power. So I know 3 times 3 gets me 9. Then you want to think, okay, what times what gets me x squared? Well, that's just x to the first times x to the first. So our final answer, 3x to the first, but we don't have to put that. Okay, 2 more problems here. I'm going to convert this one to radical form again. So my index is 3. My radicand is 8x to the third times 1 for the numerator, but we don't need to put that. So I know I need 3 things that multiply to give me 8x to the third. Well, what multiplies to give me 8? That's 2 times 2 times 2. And again, this is going to have to be x to the first times x to the first times x to the first to give us that x cubed. So my answer is 2x. And for this last one, we got an index of 2, radicand of 36x to the 6th. So I need 2 things that multiply to give me 36x to the 6th. 6 times 6 gives me 36, and then x to the third times x to the third gives me x to the 6th power. If we add those 3's, that's where we get the 6 from. So our final answer for that is 6x to the third.